Hey guys, I'm back again. Okay, I'm back again with my trusty friends. That would be my color pens. I didn't know I had skills like that, did you? Okay, today we're doing video notes 8, which is using models to solve equations. So this is going to go along with your video note 7. So we're actually going to be solving algebraically along with doing our models. So you can go ahead and start filling in the blanks that you see right here. And it's basically telling us what we're going to be doing is we can use pictorial models to solve our equations. And we're going to do a lift off, force off, divvy up method. So when we lift off, what we're doing is we're looking to see if we have the same thing on both sides of the equation that we can just remove, that we can cancel out. And that's what we call lift off. So that means if I have numbers, positive numbers on both sides or negative numbers on both sides, I can remove the same amount of each that I have. So it says eliminate values that match on both or opposite sides of your algebraic equation. If they match, we can remove them and still have a balanced equation. I hope my pencil is not too hard to see. Let me get a pen. Okay, step 2 is our force off. Now when we force off means we're not going to have the same thing on both sides of our equation. So therefore, we may have to force off by adding the opposites. So it says you may need to force some of the remaining values by adding opposites that can be used to cancel them. Because remember, when we add opposites, we
Elise
end up...
Yamas, please meet your right at the back of the building by the cafeteria. Elise Yamas, meet your right at the back by the cafeteria.
Sorry guys, guess you can tell I'm still at the school. Okay, as I was saying, remember if we add opposites, then we end up with what we call a zero pair. Remember we talked about that in class? So remember the zero pair is going to equal to 0. So they basically are canceling each other out. Okay, and then our last step is going to be to divvy up. And divvy sounds like divide, right? So therefore, if we are going to divvy up, then that means we're basically dividing both sides by the same thing. Because when we get our final answer, we're trying to solve for only one of the variables. So it says be sure that when you have a final answer, it is only for one of the variables you are solving for.
Uliana Vu, please come to the main office. Uliana Vu, come to the main office.
Okay, I'll give you just a few minutes to finish copying that in, and then we're starting. Okay, also just remember that we're still basically doing the same thing that we did in video note 7. So remember our main idea or goal is that we want to keep the equation balanced. So whatever we do to one side, we must do the same thing to the other side so that we don't have our scales tilted in one direction. Okay, let's get started with example 1. And remember, if I'm moving too fast, then you can always pause the video or rewind and watch whatever you missed again. Okay, I'm just going to make this a little bit smaller right quick. I'm going to do it this way. Okay, in our first example, we have x plus 2 equals 3. It says we can use the model to find the value of x by eliminating equivalent values on opposite sides of the equal sign. So we're not going to use algebra tiles this time. We're just going to use x's for x, and we'll just use plus or minus signs to represent our positive or negative numbers. So therefore, I'm going to do all of my variables in blue. So since I only have one x, that means I'm just going to put an x over here. And since I have two positives here, then that means I'm going to put two squares with positive signs in each. And the middle of our balance is basically the equal sign. So this is pretty much your equal sign right here, which you really don't even have to write. And on the opposite side, we have, and since I did my positives in pink, I'm going to stick with this same pink color, since there's 3's over there are also positives. So here's my modeled equation, because I see x plus 2 equals 3. Okay, so I'm going to see if I can lift off. Remember, lift off means I'm looking for the same thing on both sides of my equation. Since I see positives on both sides of the equation, I'm going to start lifting them off by removing the same things from both sides. So since I have a positive on the left and a positive on the right to match it, I will go ahead and remove those. I see that I have another positive on the left, and there's still another positive on the right side to match. So therefore, what I'm left with is my x. It equals this one positive that's left on the right side. So into numbers, we would translate that as x equals 1. That would be your final answer. Okay, now as I said, we're also going to be solving algebraically. So let's see what this is going to look like when we solve algebraically. Okay, we started with our equation, excuse me, which was, let's write that up here. We started with x plus 2 equals 3. Sorry. It's positive 3. Okay, so what we did was we removed 2 from this side. So if I remove 2, does that mean that I took away or subtracted 2? And on the right side, I did the same exact thing. I took away 2 from there. So that is why when we did our video notes last night, we did the opposite. And notice the opposite of this plus would be minus, or the opposite of positive is a negative. So I'm still doing my inverse operations, which is what the note said to do last night. So the 2's will cancel, which still leaves me with x equals 3 minus 2, which is 1. And remember, we can still always check our work. So if we want to check, we're going to put a parenthesis in place of the variable, write the rest. Now plug in your solution, which is 1. And since 1 plus 2 equals 3, then 3 equals 3. So it does check. Okay, you're going to pause the video and try example 2. We'll check it in class. Okay, let's look at example 3. Now in example 3, this time, sorry, didn't mean to do that. This time we have a subtraction equation, excuse me. But notice, if I start to group my numbers, excuse me. Remember, I'm doing my variable in the blue color. But this time I have a negative variable. So I'm going to do my negative variables in my purple which I seem to have in place right now. And remember, all my positives were in pink. So when I draw this out, I'm going to put 1x. Now I need 2 negatives, and it's going to equal 3 positives on the other side. So now when I look at this, I don't have anything that I can just lift off because I don't have negatives on this side, neither do I have positives on this side that I can lift off. So the only way that I'm going to get rid of these 2 negatives, because remember, we're trying to isolate our variable. So that means I want to remove whatever's on the same side with my variable x. So that means these 2 negatives need to go. So the way that I remove, excuse me, anything is I do the opposite. So that's why it says we're going to add opposites. So therefore, the opposite of negatives are positives. Since I added these 2 negatives, these make a 0 pair, so they'll go away. These make a 0 pair, so they'll go away. Now remember, this balance says whatever I do to one side, I must do the same thing to the other side. So since I added 2 positives to the left side, I'm also going to have to add 2 positives to the right side as well. So now what I actually have is my x. And it equals, and I actually have 5 positives now. So therefore, what my answer is really telling me is that x equals 5. Okay, let's solve algebraically just to make sure that that is correct. Okay, so algebraically, write down the equation first, which was x minus 2 equals 3. So algebraically, remember, since we have subtraction right here, we need to do the opposite of subtraction to remove that variable, which will be to add. So therefore, I'm going to add 2 to both sides. Those 2's will cancel, leaving me with x equals 5. So we get the same answer. And just to make sure we didn't mess up both places, let's go ahead and check it. So write your parentheses for your variable. Minus 2 equals 3. Plug in your solution, which is 5. Since 5 minus 2 equals 3, then we have 3 equals 3. So therefore, it does check. Okay, go ahead and pause the video right now, and you're going to do example 4, and we will check it in class. Okay, in example 5, we don't have a balance here, but we don't necessarily need it. Okay, we have, sorry guys, email coming through. We have a multiplication problem. So we know the way that we solve multiplication is we have to do its opposite, which is divide. Exactly. So therefore, what we're going to draw here is we're going to draw 3 positive x's. And it's going to equal 6 positives. Now, the way that we're going to do this is when we look at our model, we have nothing to lift off because there's no positives over here. There's no x's over here. We can't even force anything off because all I have are variables over here and just numbers over here. So there's nothing to be forced off. So I'm going to have to go to divvy up. So when I divvy up, what I'm going to do is I'm going to take my x's and I'm going to spread them out one by one. And then I'm going to divvy up these positives to them. So it's just like when you were in school or if you're in class and you and your friend were passing out candy, you said one for you, one for me, one for you, one for me. That's basically what you're doing. So therefore, we're going to take this first positive and we'll give one to the first x. The next x needs a positive, so we're done with this one. Done with that one. The next x is going to need a positive. Done with that. Since I still have more positives, let's go back and start all over again. This x gets a positive. This x gets a positive. And the last x gets another positive. So therefore, basically what I have is I have 3 groups here. But in each group, I have that 1x equals 2. And remember, I'm trying to solve for 1x. So therefore, my solution is x equals 2. And the way that we would do that algebraically is that we would write our 3x equals 6. And since I have multiplication going on in the problem, I would do its inverse operation, which is division. So therefore, I would divide both sides by 3. So my 3's would cancel, leaving me with x equals 6 divided by 3, which is 2. And we can always check, which I didn't leave you much room for, but we can slide right over here to the side and do that. So we have 3, put parentheses where your x is, equals 6. Plug in your solution, which is 2. Since 3 times 2 equals 6, then 6 equals 6, so it does check. You guessed it. We're doing example 6. Now, please don't forget, there is a negative 4 sitting in front of the variable. So remember on video note 7, you must divide by whatever is in front of the variable. And remember when we did the algebra tiles and modeling, if there is a negative in front of that number, then that means your variable is negative. So keep that in mind. Okay, pause the video, do example 6. All right, we have one final example to do with you, which is example 7. It says 3x plus 4 equals negative 8. That is a negative 8. Just going to write over that. So that means on my balance, I'm going to put 3 positive x's and on the same side I need to add 4 positives. Now on the opposite side it says it equals negative 8. So that means I need to add 8 of my negatives. That's kind of big. Now I'm going to go through my steps. So first, we need to check to see, can we lift off? Do you see the same thing on both sides? So that means I need to look over here. Do I see any X's? No. Come to these pluses. Do I see any pluses over here? No. So therefore, I cannot lift off. So after lift off, the next thing that we check for is to see if we can force off. So since I have numbers on both sides, which are represented by my plus and minuses, that means I'm going to force off. So remember, we always want to remove whatever is with the variable. So that means these positive 4s must go. Remember, we are going to add the opposite whenever we force something off. So since these are positives, then I need to add negatives for each positive that I have up here. So once I group them, I end up with my 0 pairs. So they basically are all going to cancel. Remember though, whatever I do to one side of my equation, I've got to do the same thing to the other side. So since I added 1, 2, 3, 4 negatives to my left side, I need to put 4 negatives on the right side. So now what I'm left with is I'm left with my 3x's. And I still have all these negatives over here. So I have basically 12 negatives. That's basically what I have right now. So now that I have forced off, I still have 3 x's. Remember, I'm trying to solve for 1. So since I have more than 1, I still need to divvy up. So remember, to divvy up, I'm going to split out my x's one by one. And then I'm going to divide these negatives amongst these x's to where I'm trying to give them all the same amount. Because I don't need any of these x's hollering and crying, she got more than me. Know how y'all do. Okay, so I'm going to take my first negative, and I'm going to put it with the first x. Then I'm going to take my next negative and put it with the next x. Then I'll take the next negative and put it with the third x. Now start over. This negative goes to the first x. The next negative goes to the second x. The next negative goes to the third x. So start over again. The next negative goes to the first. This negative goes to the second. This negative goes to the third. And since we have 3 negatives left, and we know we still have another x to go to the first, another x to go to the second, and another x to go to the third. Now I'm out of x's and I'm out of negatives. So therefore, what I see that I have in each one of my groups is x equals 4 negatives. So therefore, x equals negative 4. Okay, let's solve algebraically and check. Okay, my equation was 3x plus 4 equals negative 8. So remember, we're trying to isolate our variable. So therefore, we're going to do SATMAP, which is PEMDAS in reverse order. So since I have multiplication and addition, the first thing I would do is subtraction. And that's basically the same thing that we did here, right? Because we canceled out everything over here, which means I subtracted all of these positives that were over here. So basically the same thing. Excuse me. So therefore, I'm going to first subtract 4 from both sides because I put 4 negatives over here. And I also put 4 negatives on the right side. Those 4's will cancel, leaving me with 3x equals negative 12. Okay, the next thing when we're solving algebraically is since we have multiplication, we do its inverse, which is division. So that means I now need to divide both sides. Very good. By the 3. So divide by 3 here, divide by 3 here. So those 3's will cancel, and that leaves me with x equals negative 12 divided by 3, which is negative 4. Okay, let's check. Right, 3, put parentheses where your variable is, plus 4 equals negative 8. Substitute your your solution, and solve. 3 times negative 4 is negative 12. Plus 4 equals negative 8. Negative 12 plus 4 is negative 8. Since negative 8 equals negative 8, that does check. Okay, now you try example 8, and that should be the end of your video notes 8 with all examples. So please make sure that when you come in tomorrow, you have your other 4 examples that I did not do for you completed, and you're ready to roll and do some practice problems. If you missed anything or need to see it again, of course, to just replay the video and make sure that you come in ready. Have a good day, boys and girls.